Okay, so back to do these examples. So this is find the x-coordinate of the local extrema of the function f of x equals 1/2 x minus sine of x on the interval 0 to 2 pi, and justify. So remember that in order to find these relative extrema, the relative extrema can occur at the critical values. So for continuous functions, it's happening at critical values. For non-continuous functions or discontinuous functions, it can happen at critical values or any discontinuities. So to find the critical values, we look for all the points where f prime of x equals 0. So f prime of x is going to be 1/2 minus cosine of x. We'll set this equal to 0. So we need the points where 1/2 equals cosine. And cosine equals 1/2, if you think of your unit circle, at x equals pi over 3. And x equals 5 pi over 3. Okay, so you can use these points, make our little number line. So at pi over 3 and 5 pi over 3. You can plug in various numbers. So here we could plug in 0, pi over 2, and maybe 2 pi. Easy things to evaluate here. And remember, we're thinking about this in the derivative. Okay. So if I plug in 0 into cosine, I get 1/2 minus 1. 1/2 minus 1 is a negative number. That's negative. If I plug in pi over 2, then I get 1/2 minus 0, which is positive. And if I plug in 2 pi, again, I'll get 1/2 minus 1, which is negative. As you can see there. And just as I said on the previous page, we want to make sure when we write a concluding statement communicating the type of sign change at f prime of x for each of the critical values. So we just need to describe what's happening at each of those values. So since it's going from negative to positive like this, you know there's a local min at x equals pi over 3 because f prime of x changes from negative to positive. Another way we could word it for this one, so here's my other critical value, 5 pi over 3, we could say at 5 pi over 3, f prime of x changes from positive to negative. So there's a local max. Okay, so it's going from negative, and then it turns to positive, and then it's going to negative again. So there's the minimum and then the maximum there. Maybe it would be better to draw here. It's going from negative to negative again. So it looks something like that. Minimum, maximum. Okay. Go ahead, pause. Try this one on your own. Pause it, pause it, pause it. Okay. This is what this will look like. We need to find the critical values. So find where g prime of x equals 0. G prime of x is 30x to the 4th plus 132x to the 3rd minus 90x squared. And that's it. Set this equal to 0. We can factor out a 6x squared. And I'm left with 5x squared plus 22x minus 15 equal to 0. You were probably so annoyed when you have to factor this. Maybe you just waited for me to do it for you. This factors to be 5x minus 3. Use Xbox if you need to. X plus 5, 0. This is kind of a dead giveaway since this is a prime number. We know 1 needs to be 5 and 1 needs to be 1 though. And from there, it's not too shabby. Oh, where'd it go? I'm seeing a mistake. So this should be 5x plus 5x minus 3. Mobby. Maybe I'll just use a darker number. So this will be the right. Now I'm tweaking myself out. Oh no, I've got it right. Okay, cool. Sorry, I got it right. Okay, so that means that x equals 0, x equals 3/5, and x equals negative 5. These are my critical values, and I want to see what's happening to my critical values at these points. So negative 5, 0, 3/5. Plug in the values here. If I plug in negative 6, I would get a positive, negative, negative, which is positive. If I plug in negative 1, I would get positive, negative, positive, which is negative. If I plug in something smaller than this, like 0.5, yeah, 0.5, I would get positive. If I plug in 0.5 here, I'd get negative, because this would be 2.5 minus 3, so that's negative, and this would be positive, so this part's negative. If I plug in 2, I would get positive, 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 which is positive. So this one's a little different. It's increasing to decreasing. Even though it hits a critical value, it's still decreasing here, so maybe this looks like a cubic. Maybe something like this. And then it's still decreasing to increasing. I did a terrible job of that. Decreasing all around there. There. So here I have a maximum, and here I have a minimum. Okay, so to summarize this, you could say there's a local maximum at x equals negative 5 because f prime of x changes from positive to negative. And there's a local min right here at x equals 3/5 because f prime of x changes from, now it's going from negative to positive. Cool. Alright, in this one down here, again, this is just the same thing. Find the relative extrema. So, looking for critical points or points of discontinuity. Remember, we could also have points of discontinuity. So let's look at f prime of x equals, this is going to be 2/3 x squared minus 4 raised to the negative 1/3. Then chain rule, got to multiply times what's on the inside is 2x. The derivative on the inside is 2x. So this simplifies to be 4x over 3 is the cubed root of x squared minus 4. If we set this equal to 0, we don't actually need to solve this. The only values of x that will make this thing equal to 0, oopsies, that will make this thing equal to 0 are going to be x equals 0. So this is a critical value where that happens. But another thing we need to consider is that this function here is not always going to be continuous. This is going to have a point of discontinuity when x equals plus or minus 2. So if I plug in plus or minus 2 here, I have a discontinuity here because of this fractional exponent like that. Okay, so these are all the points that I need to check out. So when I make my number line, I'll be going -2, 0, and 2. And I need to plug these numbers into here. Well, like I need to plug numbers in between here, actually. So when I do that, I'm not going to show you my steps, but when I do that, you should have gotten a negative, positive, negative, positive. So going down, then up, then down. So I have 2 minimums and 1 maximum. So you can say f prime of x changes from negative to positive at x equals -2 and x equals 2. So these are relative minimums. And then f prime of x changes from positive to negative at x equals 0. So this is a relative max. Okay. A slight difference in this problem. The previous one just to find the x-coordinates of the local extrema. So this said find the x-coordinates. This is saying to find the actual extrema. So in order to figure out like what the extreme values are, the local or relative extreme values, you could plug in, so you could find f of 2 equals whatever that value is, and you find f of -2 equals whatever that value is, and then solve for f of 0, and that will give you that value. Okay. So these two up here, f of 2 and f of -2, are going to be 0. And if we plug in f of 0, we will get the cubed root of 16. So this is my relative max value, and these are my local minimum values. Okay. Here we go with these ones. I'm just going to do part A here, because these are very similar, and they use a similar trick. I foresee this being a little tricky for some people, so I do want to do it. Here we just need to find the x-coordinates, so we don't actually have to plug back in to find the values. If I take t, well, first I'm going to rewrite t of k, because I want to write this as a fraction. So this t of k equals k to the 2/3 times 2k minus 1. Just rewriting there. Now I will switch and find t prime of k. That's going to be, I got to use the power rule, or product rule. So this is going to be 2/3 k to the -1/3 times, this one stays the same, plus, now the first part will stay the same, and I take the derivative of the second part. Okay. Yes, I gotta simplify this, just like you do. So I'm going to distribute this one. I'm going to distribute it here and here. And I'm going to get 4/3 k to the 2/3 minus 2/3 k to the negative 1/3 plus 2k to the 2/3. Still just doing algebra. Still just doing algebra. Remember though, we are setting this whole thing equal to 0. So I can say this thing equal to 0. Let's combine like terms. 4/3 plus 2 is going to be 10/3 k to the 2/3 minus 2/3 k to the negative 1/3 equals 0. Now we have to do that funky factoring that we've done in class before. So really funky factoring. Let's take out what they both have in common. They both have in common a 2/3. We can factor that out. We can also factor out a k to the negative 1/3. Oh, the bell's gonna ring on me soon. So I factor that out and I have left 5k minus 1 equals 0. So we have the k values 0 and k equals 1/5. And we would use those values here. 0, 1/5. Plug in values in between into f, or I guess t prime of k. So plug them into t prime of k and you get positive, negative, positive. So here you have a max and here you have a min, which you could write out. Okay. I'm just going to zoom out and show you the answers to the other ones. So this was all the nice concise work for that one. Please try the other ones on your own and you can compare your answers with this. In the end, you should get tables that look like this one and that look like that one. Wow, that's super messy. Ta-da! So look at my work. You can look at my work. Okay, I've got to go teach class. Bye.